Hello and welcome back to Python, and today I won't do a tutorial, but I want to show you 5 cases where recursion can be used to easily define a function instead of, maybe it is possible by doing it without recursion but using much more code, or it isn't even possible. And let's do it. So as a quick reminder, what was recursion? Recursion is you have a function like, for example, def factory, which takes a number and if n equals 0, it returns, else return n multiplied, it should return 1 multiplied with factory. Now we are calling the function inside the function, and it's the same function, n minus 1. So what we are doing, first we are having the case when the function should stop and return, and then the case when the function should call itself. And now if we run our function, we are getting 6 because 3 multiplied with 2 multiplies with 1 equals 6. Pretty simple, but it might be confusing first, but if you are just thinking about that you first have the case where the function has to kind of stop and do it with an if statement, and then you have else, and you have the case where the function calls itself. And what is important is that you somehow reach n equals 1. So don't think about just using n, because then you will see it gets an exception. So I talked a little bit too long regarding a recursive function by itself, but here we get the first example. So if you're, for example, factoration, you can also use a loop and having a value, decreasing it by each time the loop iterates, but that's our first example. Now what you can do, and that's I will define a list for that. Let's call it the list. Now I will stop recording and creating a little list. So I created a list, and what we are gonna do, we want to count each number in the list. That's the second example. You have complex lists and you want to do something in the list, but the list also contains list and so on. So we are having def, let's just count the ones, def count 1. We have L is a list, and for element in L, if is instance element list, because we have to think about the case we are getting another list. And for that we should also declare our count. So we need a variable like count equals 0, and then of course count 1 element is count plus the count 1 element, else elif element equals 1, count plus equals 1. And yeah, after the loop return count. Now let's see if this already works. Count 1, list the list. Yeah, we have to print it, of course. And yeah, let's count. 1, 2, 3, 4, 5, 6, 7. Got every one. So that's the second case. If we have like complex lists, you can do the same with dictionaries, with yeah, all kinds of storable data type. Now let's get a little bit more complex, because the first two cases were already kind of solved in my recursive video. Now let's dive a little bit deeper. If you are studying computer or yes, IT related subjects, you maybe know what comes next, because we are kind of we are now have the class node. Class node is, maybe you can compare it to the list data type in Python, because it's nearly the same. We have one node which is connected to the next node, which is also connected to the next node, and the last node is simply none, so not an element. If you're not understanding what I mean, I will just write the class, and maybe by hearing me reading the code you will know what I mean. First constructor, then we have our element and neighbor. I call it just neighbor, and self point element equals element, self point neighbor equals neighbor. So the fun thing is that the neighbor is another node. So let's create our own list containing only nodes, and this is not a list you have in square brackets. We have list node list 1 equals, let's comment this one out, and this one. We have our node, our element, and another node which has an element, and another node which has an element, and another node which has an element and another node. And of course the node has an element and none, so that we are at the end. Now when we usually without recursion want the third element, we have to print node.neighbor point neighbor point element, and I have to write it correctly, did I? Why is he underscoring? Just try it. Yes, maybe I mistyped. No, I didn't. Oh, I have to use node list, not node. Node list 1 neighbor, and now he printed 3. Let's uncomment this either. Now we get our 3, which is the third element, and we have to add another neighbor point element if we want to reach here, and so on. But that's if we have like 30 elements, this will be too much typing. So what we're gonna do, def get element, self, and position. And now we can, this is really, now we are really starting the third case, because Now we have recursive function which doesn't take only one argument but two arguments. If pos, it's really simple. If pos doesn't equal 0, return get element self point get element -1. No. Pos -1. And yes. Else return self point element. And now if we print node list point get element, for example 5, okay, we are getting 1. Now I'm okay, I did something wrong, but yeah, let's see. What did I did wrong? For debugging, let's just type print a. Okay, he's doing it right. Point element. Okay. I'm so stupid. This is kinda embarrassing because self point neighbor point get element, of course. Embarrassing. Now we finally reached 99 because yeah, that's the 5th element. Sorry, this is really embarrassing, but yeah, mistakes can happen. Yeah, this is the 3rd case. Now let's do the next case. Let's do a magic method. Let's define the string method of our own list. We have its return. We want to return a string f, beginning with an open bracket, self point element and self point neighbor point point. No, not like this, like this. String of self point neighbor. And yeah, now let's print node list 1 and let's see what happens. This is kinda cool. He's now printing every element of our list recursively. Let's use commas. Now he's dividing it by commas. And yes. Now if we want brackets, we can, for example, define a variable. We of course used to have a default parameter because we don't want to print it giving it another variable, so we are giving self pos 1. If pos equals 1, comma 0, and else we return the code from previous. Now it won't get the ending bracket, but we should get a starting bracket. We just have a look, pause. Okay. Okay, now I learned something for myself. Okay, now after many tries I finally got it. So you have to, this can work if you have a string and an additional argument. Still, if you have a magic method, it is possible. First we have the case like I already mentioned, and yes, I tried a little bit lately. If position equals 1, we return f as a string, self point element, and now it gets complicated because I didn't think about that node, and yeah, not the object but the class node. Now string, now self point neighbor, and yeah, 0. Now elif self point neighbor doesn't equal none. I guess we have to type is none, but I will handle this when the code is partially working. Now let's just see if this one works. Yes, it does. So again, we want to separate anything with a comma. And here again. And yeah, last case should be else return f element, and with a closed bracket, then open bracket. And finally we got it. Now if we print our list, we have the same as we would print, yeah, a common list. That was, yeah, that was a challenge on its own, but pretty cool. I had fun making that. And yes, now case 4, because we are, oh no, this is case, I guess this was case 3, this is case 4, and now a last case. For that we are creating a binary tree, class bini, and yes, has an element. I hope you know what a binary tree is. Binary tree is like we have like a list, but one node has like 2 nodes, and yeah, these nodes have also 2 nodes, and so on. Like you are, yeah, and each section you get double the nodes. Let's just call it binary node with 1 underscore, self point init, def init. Yeah, all my brain power is already lost because of the last one. But hey, I'm happy we did it. We have a list. We recreated the list data type, which is cool by itself. So now we have init. We are having the element node 1, node 2, self point element, no, self point element equals element, self point node 1 equals node 1, self point node 2 equals node 2. And yeah, let's create a binary tree. Binary node equals, but yeah, let's call it bn because the code we are writing shouldn't be so long. So let's call it binary L for binary list equals bn to bn 3 non bn 1 1 bn 3 and by the way, if I let's get default parameter, let's get default variables. Because if I'm not typing non node 3 equals bn 1 bn 3 bn 4 and let's bn 1 bn another bn Okay, I kind of made a mistake. Yeah, because I think I know it. So this is a mess up. Even by myself, I don't have anything I don't even know what I just wrote, but that make it even more, let's make it even more interesting. What we want to do, we kinda want to search for the highest element, which is really one of the simpler binary tree tasks. We can have our own video regarding binary trees. And yeah, let's just type in def search highest. And if self point node 2 equals is non let's first have the case self point node 2 is none and self point node. By the way, what I totally messed up, you're always using classes with uppercase. Okay, because I messed it up so badly. Let's do a refactor. Rename node and rename bn. Okay, back to it. Is non return self point element, return max of self point element and self point search tires self point node 1. The same goes for if the first one is none. And yes, let's do an else if, of course. And now else return max self point element self point search tires self point node 1 self point search tires self point node 2. Let's try it. I'm a little bit nervous if it will work. Print binary search highest. Okay, yes, I'm stupid. That's why I don't even need an argument. Self point node 1, self point node 2, self point node 1, self point node 2, and here maybe I missed one. Okay. I get the mistake. Here is one bracket too much. Okay, this one has to be deleted as well. Okay, of course, because the function I just created only works with integers. Now I got it. So yeah, sorry for the cut, but I had to test something. Now this is a function that works. We have first the case if everything else except the element is none, then he has to return itself. Then one node is none. He returns the other node. He returns the maximum value of the other node, of course recursive, and itself. And yeah, if the other node is none, he uses the function again by the node which is not none, on the node which is not none, and itself. And yeah, if both nodes are kind of not none, he will return the max of itself and the function of the other two nodes. Yes. And we got 9, and we can try it again by placing 3, 3, 3, and he get us 3, 3. Yeah, that was number 5 if I counted correctly. Otherwise I will just rename the video to 4 examples. I hope you had fun watching the video. See you in the next video. Bye bye.